Well, good morning, everybody, or afternoon, depending on where you are. So, welcome to our webinar. So today, I can see that I'm still waiting for a few attendees to connect. Let's just give them a few seconds, and then we can get started. Okay. So as you know, today's webinar is going to be about the new Meteodyn WT features. And joining me today is Dr. Edouard Leonard, and he's a senior wind engineer and an expert on the software. So Edouard, if you want to say a few words.
Yes, thanks, Juan. So hello and welcome to all of you to this webinar. Thanks for taking the time to join us today. So let's start.
Yes, thank you, Edouard. So you mostly know me. My name is Juan Camilo Daza, but I'm the business development engineer for Meteodyn. So yeah, let's get started. So as you know, many functionalities have been included because you requested them. So as you know now, Meteodyn WT is part of Meteodyn Universe. So today we're going to be talking about the new functionalities that were included in version 1.5 and 1.6, which you guys may already have if you are up to date with your technical support and software updates. Okay, at the end, we're going to have some questions and answers that we're going to treat for you guys. So feel free to just punch in the questions to the chat box and then we'll respond them at the end. Okay, so as you know, and now the software has been converted into a full platform. And we also have 4 new software products that are in the platform as well. So today we're mostly going to be talking about Meteodyn WT, but just for you guys to know, we also have 4 other software products. So GCS, which is the Global Climate Data Service for downloading mesoscale data anywhere in the world. WDA, so wind data analysis software for analyzing wind data, completing, flagging, performing in CP. WFO, so the wind farm optimization software for wind farm optimization layered-wise. And WPA, so the wind farm performance analysis software to analyze the performance of wind farms, monitor them, and turbine by turbine or the whole wind farm. So once you come into the home page, you see your 5 products if you have them. If not, you'll see the ones you have installed in your computer. Okay, so let's get started with the first functionality I have for you guys today is the digitalization tool for the Roughness correspondence file. So what this means is that now you can modify your Roughness file within the software if you wanted to do this. So this only works for TIFF files, and you can create a new correspondence file. So let me just go into the software. So yeah, so when you land on the software, you land on the home page after you sign in. And then, of course, today we're going to talk about WT. And once you go in here, you have all the sites that are here on the left. So I wanted to make this site for you guys today. So it's a site in Greece. And it has a lot of stuff that you would expect to encounter. So in this case, the site is a very complex site. As you see, it's an island, so ocean on both sides, high mountains here. So we have about 700 meters of altitude here, and it's just about 2 kilometers from the coast. Okay, so let's go into the site. And once we go into the site, you have the first site settings. Your information, projection, simulation, etc. So you usually include your Orgraphy and Roughness data to start with. So that's what we're going to talk about now. So if you go into the geographical data tab up here, and then you select Roughness correspondence, select the file you want, you go into it, and here we have the Roughness correspondence file I was talking about. So if you click on any point, you can see all the zones where this Roughness is applied. So in this case, it's 0.03 meters. And so if you wanted to modify your file for, let's say, the 11 value to something else, you could change it here, and you can save a new correspondence file. So this is very useful for you guys if you knew that, for example, one value was replaced by another value for some reason. Sometimes forest gets modified, and you know all the forest files you can modify. So that's going to help you guys a lot without redoing your files. So the next functionality we have for you guys today is also about orographical data. So now we can overlap different types of elevation files. So this is really useful if you have smaller files and you want to add another big file behind it. So it's going to take the first one in priority and then the second one. So this is going to complete your file. So it's going to help you out. So let's look at this inside the software. So once we're inside WT, the site simulation configuration, you can see here we have the orography and roughness sections. So in this case, I placed two files. So the one that gets added last, in this case, SRTM 30 meters, is the one that's going to be taken in priority. So this only works for TIFF files or GeoServer data, which is already in the software. So I added, the first file I added was the 90 meter SRTM Meteodyn file, and then I added the 30 meter file. So in this case, if the software were to encounter some holes in this file, he would use the second one. But you can also do this for your files, of course. Same thing for the roughness files. So I did 100 meter resolution, and then the second one priority is 300 meter resolution from the ESA Space Agency. Okay, so yeah, that's gonna help you guys a lot. Just so that you know, here we have this is where we are in microscale simulation. You have the geographical data, meteorological data, wind turbine types, and later data correction up here. Okay, so let's go back to the presentation. So the next functionality for you guys today is the fact that now you can create multiple mappings as elements. So this can be with they can be for different heights, different areas, or for the same area and different heights. Okay, so let's look at this inside the software. So in this case, in the element section, you can select multiple mappings. In this case, I have two. So as you can see in this site, I wanted to do an offshore wind farm and an onshore wind farm. So I create two mappings so that I can have results in these points. So remember, a mapping is just a series of points in a regulated grid. So in this case, you select the height, you select the step, and you select the coordinates where you want the mapping to be. And the second mapping I did was for the onshore farm, wind farm, which is right here. Okay, so once we want to look at the results, which is right here. So we click on the little I button here and we get the results. In this case, we have variable results, but let's look at wind speed, for example. So mean wind speed in all directions. So let's just wait for the results to load up. And once results load, you can see that for the offshore wind farm, we have exactly what we would expect. So the wind slowing down as it comes into the coast, as is expected, as is usually the case. And of course, for the onshore wind farm, the wind is very regulated. As you know, the site has forests, mountains, etc. So it's very, very complicated. Here you see the legend and wind speed. So this is automatic. But we're going to talk about that later. Let's go back to the presentation. So next up is a functionality related to the CFD computation, and I'm going to let Edouard take this one.
Yes, thanks, Juan. So now I would like to talk about the CFD computation. Well, actually, we provide 5 very interesting advanced features regarding the CFD computation, and one significant improvement in the solver. Okay, so I will start with the improvement in the solver. So actually, we have modified some boundary conditions in the Navier-Stokes equations. Okay, so we provide more precisely new boundary condition in the turbulent kinetic energy on K. Okay, so I don't want to go deeply into the details, but what I can say is that we are now considering the extreme values of K with more precision. Okay, so as a consequence, there is a significant improvement in the CFD convergence, okay, and especially for complex terrain. So on the next slide, I have some examples. So we have tested this new solver on 500, sorry, on 50 sites and all the stability classes, and we observed an improvement for more than 500 cases. Okay, so you will observe some improvement in the divergence cases, or when the convergence was low. So of course, when the convergence rate is lower than 95%. Okay, of course, there is a very low difference when the convergence was already high in the previous version. So you can see on this graph, okay, the influence of the new solver on the number of convergence cases on 7 sites that are very representative of complex terrain, and you can see that the number of divergence cases has been decreased significantly. Okay, so you know that one real advantage of the WT product is to be based on the Migal solver. So the Migal solver is our homemade solver. Okay, and this enables us to conduct research to improve continuously the performance and the results of the CFD computation. And this is a very good result and a good example of this type of research.
Thank you, Edouard. So as you know, guys, CFD computations take up quite a bit of RAM memory in your computer. So of course, I know you guys launch computations at night, and of course, you don't want to arrive in the morning and find out that the computation failed just because of memory wasn't enough. So now you can estimate the memory before you launch a CFD computation. So let me just show you this inside the software. So in the CFD part, when you want to configure a new computation, you enter all the details, let's say every 30 degrees. And here you can estimate the memory that this is going to take. So in this case, you already know that for direction 30 is going to take 13,143 megabytes of memory. So you can check this before you launch computations, and then you won't have any problems. Okay, so let's go back to the presentation. So next functionality we have for you guys today is you can now stop and get the results of a CFD computation that is still computing. So if, for example, you were already if you're already happy with the convergence rate, you can now stop a CFD computation and get the results without having to wait for it to complete the full iteration that it has to complete. Okay, so moving on. This one's for Edouard.
So yes, thanks, Juan. So this is another very interesting advanced feature. So you know that in the previous versions, okay, of the CFD computation, the computation stopped when the convergence limit of 100% was reached. Okay. However, the convergence limit of 100% is just representative of the ratio between the initial residuals and the final residuals. And of course, many users were interested to go beyond this limit to improve the convergence and of course obtaining better results. So now it's possible. So you can use the option force all iterations using this this option in the advanced features of the CFD computation, and you will use all the iterations during the CFD computation. So you can see on the table, so the first column is the number of iterations. The second one is the convergence rate. Okay, then you have the maximum residual without and with the new option. And you can see clearly that using the new option, of course, you can go beyond the limit of 100% and you can improve the conversion. So in that case, you reduce the maximum residuals.
Okay, so next slide. Now you can customize the legend for the display results. So before, when results were displayed, the legend was automatic. Now you can customize this for the CFD results and the synthesis results. So let me show you this inside the software. So let's look at this inside the synthesis. So here we have results, and as I said, the scale is automatic. But if we go into this little gear and then into this other little gear right here, you can modify the values and the step, etc. So you guys can have much cleaner results. Okay, so moving on to the next functionality. Now you can display the CFD results in all the refined computational domain. So this is a functionality that was requested from quite a few of our clients. So let's look at this inside the software. Okay, so this is for the CFD part. So let's just get rid of the synthesis results here. Okay, and let's go to the CFD part, to the result part. So let's say for 30 degrees, we can click on the little eye to so that we get results. So in this case, I don't want results in just the mapping. I want it for the whole domain. So for the whole domain, when I click this, and then I have to select a height, usually 80 meters for this wind turbines that I placed in this site. We're gonna get results for the whole site. Of course, this is gonna take a few seconds since software is calculating the results, calculating the to display them. So in this case, since it's 30 degrees and stability class 2, you're gonna see that the wind is coming from the northeast. So you're gonna see the square is slightly inclined to the right. Okay, just to remind you guys, these and other functionalities have been requested by you guys, so you will have the chance to continue to do this. So here we have the results. So in this case, results are, since it's CFD results, we have the speed up factor results. So here we go. And as expected, of course, offshore is very nice, but once things get onshore, we get many different colors, many different speed. Okay, let's go back to the software. So the next functionality we have for you guys, as you know, you can use multiple computer processor cores to launch the CFD computations, but now you can also do it for the synthesis. So this is going to drastically remove the synthesis computation time. And as you can see, we have a graph here on the right. So if, let's say, computation was taking 100 units of time, now you can do it in 1/3 of the time using anywhere from 4 to 6 cores. I recommend people to use 4 cores, which is very optimal. You can leave other cores available for other tasks in the computer. Okay, now I'll let Eduardo talk about the synthesis computation.
Yes, so I would like to summarize actually the different tools we provide to analyze the results of the assessment of the IEC norm. Okay, so you know that edition 4 is now available for more than 1 year in WT, but we provide several tools. Okay, so the idea is to show you the different approaches we have. So of course, terrain complexity and the IEC compliance rules can be analyzed in the software. So we have here an example of the different rules with a specific color code, okay, to see quickly if one rule is or not in good agreement with the IEC norm. So we have one quick analysis panel dedicated for preliminary analysis. Okay, so using this option, you can select the terrain complexity analysis or the validation rules using the summary or the detailed analysis, and you have here several tables, okay, with all the details of the results. Regarding the terrain complexity, you have here for each wind turbine the category, okay, if not complex, if it's complex, with the different category, low, medium, or high. Okay. If you want to go more deeply into the details, we provide some customized advanced IEC export. Okay. So you can see here the several options you can select. So the 5 first options are dedicated to the comparison between the different variables. Okay, so it means that here on the preview panel, you can compare the different, for example, the wind distribution for each between each wind turbine. Okay, if you select the last option, so export the selected turbine in the specific sheets, you will obtain the very standard exports, including all the results for each wind turbine. Okay, and of course, if you use the export IEC summary button, you will export of all the data displayed in the preview in an Excel IEC format. Okay. So of course, here you have an example of the Excel file. So I will show you on the software. So when you go on the synthesis result panel, okay, now you have a specific panel here for all the different exports. Okay, so you have the auto report export, the Excel global export. Okay, you have here one IC export, WG, RSF, okay, and so on, the Google Earth export, the Sulfur, and the OpenWind export. So when you go down, okay, you have here access to the different result panel related to the IC. Okay, so you have here the quick panel analysis, and you have here access to the advanced export options. Okay, so you can see the preview here with the comparison between the different variables, and when you go on this specific page, you can see all the tables, including some graph comparing the different curves from the site, and of course the models from the IC. Okay, so let's go back to the presentation. I would like now to discuss about the wind turbine type module. Okay, so we have reorganized this module, okay, in order to clarify some points, and of course to facilitate your job in importing curves and different variables. So now there is a new category. Okay, so the manufacturer category. You can store some documents. You can now import some power curves using the turbulence intensity property. Okay, so you can define the property. So it's if it's static, low, medium, or high. Okay, you can compute the power coefficient, and of course you can display all curves and variables. Okay, so now so you know that different modules are located on the top here. So this is the wind turbine type module. Okay, so when you open this button, you arrive on this list with all your wind turbines. So I will show you, for example, with this Vestas type. Okay. So you can see the page has been reorganized. You have here the general properties. Okay. Then you have some manufacturer information here. Okay, so the idea, of course, is to connect the different wind turbine type with the manufacturer and detail some information like the factory, etc. So then you have the version management panel. Okay, so this is where you can import some curves. So you can open this page with this button. You can here display the different power curves related to each version. Okay, and so here you have the different power curves and thrust curves saved into this category. Okay, so of course you can here display the graph, display the power coefficient curves. Okay, and of course you have here the thrust curves, and this is the same process. You can display the curves or the data. Okay, when we go back to this page, we have the wind turbine design. Okay, of course with very important information, and here we have the certification. So in that area you can define the edition, okay, of the IEC you want to use for your assessments. So now let's go back to the presentation. I would like to present you another very interesting feature related to the CFD computation. Okay, so this is the option keep 2D mesh to allow additional iterations. So you know that the default number of iterations is 25. Okay, however, when you are working on complex terrain, sometimes you need 50 or more, sometimes even 100 iterations to obtain a satisfying convergence for the CFD computation. Okay, so now it's possible to add additional iterations after having launched a CFD computation, and for this it's necessary to select, okay, this option in the configuration page of the CFD computation. So here you can see the option, and of course you have to select this keep 2D mesh before the CFD computation. Okay, so this option can require the storage of CFD result files. So the files can be heavy, so make sure that you have enough disk space disk. Okay, so now let's discuss about other tools.
Thank you, Edouard. I'm going to take the control now. So we have some tools to improve the user experience. So now you can measure distance between 2 points on the map. And also you can display the projection coordinates and elevation under a cursor, which you are currently using. So let me show you this inside the software. So let's just get rid of these results. So so let's just do it for the mappings. And so you can of course hide all this. And so now let's say if you wanted to measure a distance between 2 points, let's say these 2 points that I created here, you can now do this. So it's going to help you guys to do some just to help you reference a little more your site. Also, if you click in the little bottom here, you can see that as I move around, the coordinates change, and also if I let it, I leave the mouse still, he's gonna calculate the elevation. So here you have latitude, longitude, and the corresponding projection, and of course the elevation in this case. Okay, so let's just hide this one for a minute. Let's go back to the presentation. The next functionality we have for you guys today is that, as you know, once you create a site, you have to select your projection. So very frequently, users use the same projection they used before, so they had to go through a whole list again and find it. Now you don't have to do this, so the projections which have previously been used are saved on the top. So this is going to help you guys just operate the software quickly. Okay, next functionality we have is that now for the post CFD process is possible for the mapping elements. So it remains possible for all elements. Now we can do it for the mapping elements as well. Be careful though. This should only be done if you already have one mapping in place. That's why we always recommend you guys to launch CFD computations only after having placed at least one mapping. So if you forgot to place a mapping in the same area or inside an existing mapping, you can use this functionality without any problem. Or for new mappings at different heights, so this is fine. However, be careful, don't use this functionality if you place new mapping outside of the mappings. This is not a good idea because the results will be based on interpolation only and not the CFD, so the accuracy may be affected. So yeah, keep this in mind. Also now we have a new results for the synthesis. So now we compute the veer, which is the difference between direction and at the highest point of the rotor and direction at the lowest point of the rotor of our wind turbine. And of course, as you know, we can deliver time series results for each time step for all configurations. So all the variables you will be able to have time series results if you have if you want them and if you have all the requirements to have them. You can see on the right here we have a huge site. You can see the label on the bottom is just 10 kilometers. So you can see each little cell here is 1 kilometer by 1 kilometer. So this site was created using mesoscale cells. So now you can you can display the mesoscale zones on the map. So this is just to help you guys a little more. So yeah, I'm not going to show you this in the software because this is takes a long time and it requires a huge computer, but know that we can do it. So yeah, to summarize today's webinar, so all the functionalities are of course keeping in mind the users and trying to reduce the computation time, improve the accuracy, have additional results, and improve your experience, of course, as well. So now it's time for the questions. Edouard, I think we have quite a few questions.
Yes, perfect.
So I'll let you take over.
Yes, so thanks for asking questions. So I will start with the first one. You showed that you have largely improved convergence. How about accuracy for these front-to divergence cases? Did you validate against measurement data? Okay, so yes, this is a very interesting question. Actually, there are two consequences to this improvement. So of course, when you are blocked, okay, when you have divergence cases, you cannot obtain results. So now you can finally obtain results. Okay, so we are now validating all these results on all these sites. Okay, so I can tell you that there is an improvement, but I would say that actually the improvement is especially served on very specific thermal stability classes. Okay, so of course the influence on my examples, for example, are not very significant on these cases, but of course we are finishing this analysis of final results, and we will probably publish some paper on the internet site to show you the real interest and of course the how your results will be improved using this new version. So thanks for this question. So there is two other questions maybe for you, Juan. When was final WT 1.6 version released?
Yeah, talking about the 1.6 version, we had this version for a couple of months now, since November. I don't remember the exact date, but of course, if you're a client, you have access to this version. If you are up to date, you have access to this version right now. If not, of course, you can contact me and we'll discuss that together. The last question is about offshore wind farms. So I'm just going to read it out. In your example, there was an offshore wind farm project. So what would be the advantage to perform CFD computations in this case? Is it interesting only for near shore projects to consider orography from the land? Okay, so in the case of offshore wind farms, of course, if they're near to the land, it's important to take into account the land. But if in the case if the wind farm were to be far from land, it's also interesting because okay, in the software we do CFD, and you could of course apply other models, but remember that in WT you can include mesoscale zones. So if you wanted to do this for one reason or another, you could do this as well. I don't know if you want to add something here, Edouard.
Yeah. Sorry, I was reading the other question, so I can maybe take another question. So how are the turbines represented? And using actuator disk, this is the question. So actually not. So the wind turbines are represented by points, okay, or profiles, okay, so a segment of points, using this during the CFD computation, and then during the synthesis, we use analytical models, okay, to simulate the wake effects. So, for example, the Jensen model, or more advanced wake models like the large farm wake effect model. Okay, but with this version, we do not use the actuator disk. Okay. Another question about the optimization process. So can you show us the optimization process? So you mean maybe the wind farm optimization process?
Yeah. Yeah, so now, just to answer this question, so now the wind farm optimization software is another software within Meteodyn Universe. So we're going to do a webinar specifically for that software in the coming months. So no worries, we're going to talk about a lot about that. But of course, if any of you guys wants a private presentation on software, we can set that up anytime. Okay, I'll let you take the next question, Edouard.
Yes, there is a question related to the resolution of the mesh size. So which resolution do you recommend setting for complex terrain? So yes, this is a good question. Thanks. So, well, actually, you know, we have a special mesh in the WT product with a special refinement around the points. Okay, so we recommend first of all to use mapping. Okay, because mapping is a grid of points, and of course you will have a very precise mesh around each point. So this is the first point I would like to highlight. And the second one, of course, is the CFD resolution. Okay, so the default parameters. So 25 meters for the minimum horizontal resolution and 4 meters for the minimum vertical resolution are totally adapted, okay, for complex terrain. So this is what we use for wind studies, and what we recommend to all the users, okay, for the CFD computation. But of course, this is always a compromise, okay, between the performance and the precision. So it depends on your machine, what the RAM of your machine, and of course the size of the site. Okay, do we have?
Yeah, the next question is somebody's addressing the question to me. So it says, Juan Camilo, when you say near the shore, how many kilometers was I thinking of approximately? So yeah, for offshore wind farms, I think I'll let you take this one, Edouard. So before I was talking about when it would make sense to apply CFD models to offshore wind farms if they were near the shore. So we have a question of how many kilometers would it be to be near the shore? So
yeah. So yes, it's a very good question. Of course, WT is an essential tool, okay, on complex terrain, but also on near offshore, and especially if you have cliff or a special topography, okay, near to the coast. So of course it depends on the size of your site, but if your site is 10 kilometers and the coast is included inside the site, of course the CFD computation can be really interesting to see the influence of course the forest and mountains and the land on the wind farm.
Yeah, also to add here, when we're talking about offshore wind farms, remember that in WT we take into account the different stabilities of the atmosphere. So here as well, if you have sites where you know the stability of the atmosphere varies, it would be also important to take this into account for your models. So we take that into account offshore and onshore. And of course, for offshore farms, Eduard, I think you mentioned it a while ago. If you have very regular and very big farms, as usually is the case for offshore farms, we have a special wake model for the big wind farms. So that would be another reason to use it as well. Okay, I'll let you take the next question, Eduard.
Yes, so there is a question related to the reference point in the synthesis. So in the synthesis, what is the meaning of reference points and reference methodology and their relation? Okay, so you know the idea of the CFD computation is to simulate the wind flow, okay, all over the site. We simulate wind turbine like points, okay, and then during the synthesis we associate one methodology, sorry, with one point, okay. So here the idea, of course, is to associate one methodology to here the reference point, and the reference methodology is very important in the synthesis because it's a kind of reference for many results, okay, especially you know that all the results, production results, okay, are given with a direction reference at the mast, okay, and the reference mast is the reference we take for giving the production results, okay. There is also the reference climatology is also reference for the definition, okay, of the thermal stability classes distribution, okay. So you know when you want to use the multi-stability process, okay, there is a distribution of the thermal stability classes, and okay, when you select the reference climatology, you will use the distribution of this mast to obtain the results. Another question about the CFD turbulence model. So can WT use another runs turbulence model as KW? So no, not for the moment. So we use a KL approach, okay, of course, using the runs approach to solve the Navier-Stokes equations. And no, so all the results are based on the KL approach, KL model.
Thank you, Edouard. Okay, that's all the time we have today for your questions. Of course, if we missed any question, please send us an email. So, of course, as I said before, you guys have contributed a lot to the development of the software. So you can submit your ideas in this webpage, or of course, contact us directly as you have been doing so in the past, and we'll take them into account. So remember that software continuously evolves and adds functionalities as they become a requirement to the users, or if new norms are employed in the industry. Okay, so we don't have any questions today, so that's nice. Um, just for you guys to know, one of the other softwares inside Meteodyn Universe is Meteodyn WT, so the wind farm performance analysis software to monitor the behavior of wind farms and each individual wind turbine. So we're gonna have a webinar on this software, and it's gonna be on the 1st of March. So registration will be open soon, and so you can look it up on our LinkedIn page or on our website. Okay, well, thank you everybody for assisting to today's webinar, and I wish you all a good morning or a good afternoon, depending on where you are. And Edouard, thank you very much for joining me today.
Yes, thank you to all of you for your attention. So, of course, don't hesitate to send us a mail if you have questions on the webinar or on the software. You have here the different mails of Juan and
Okay, thank you, Edouard. Well, thank you, everybody. Have a
thank you.
nice day,
Have a nice
and
day.
bye-bye.
Bye.